Okay, welcome to Introduction to C Programming. Today we are going to continue our discussion of programming. We're going to talk about variables and arithmetic in C. To start off, we're going to talk about printing out values in a string in C. We have a few special characters. Last time we saw that the way that we print out data in C is by using a function called printf, and then we put a parenthesis followed by quotation marks, and we can print out anything that we want to the user inside of the quotation marks. There are a few special characters that we have. We saw the new line character last time, which is including a \n. There's a tab character, \t. The alert character is always a fun one, which is the \a. This is how you can make your program go ding right in the middle of it. Whenever it gets to a printf with a \a, your computer is going to make that dinging sound. If you actually want to print out a backslash, you have to have two backslashes. The reason is because the single backslash is the escape character. It's saying that the next character that follows the backslash is a special one. It's going to be this N, T, or A. And if it's something different, then it's going to escape that character, which probably is not going to do anything inside of your print formatted statement. So if you want a backslash actually printed, you have to put two backslashes, and then that would print out a single backslash for the user. If you want a double quotation mark printed, you have to have a backslash in front of the double quotation mark. The reason for that is that the quotation mark denotes the end of the string or the beginning of the string. It's the delimiter character for a string in C. So if you want to print out a quotation mark, we have to put a backslash in front of it also, and then that can appear in the middle of your string, and it'll actually be printed out as the quotation mark character. So those are the escape characters that we have available to us using the printf function in C. There are comments in C. So comments are lines of code that are ignored by the compiler. You can write absolutely anything that you want inside of a comment. Comments are for the programmer. This is where we can document things in our code. This is the loop that is going to read in all of the data from the user. Or this is printing out to the user my hello moose line, something like that. This is comments just to the programmer. The compiler doesn't care about it. The compiler ignores absolutely every comment that you put inside of your code. You have two different types of comments in C. The first one is a single line comment, which starts with two four slashes, and that would be a single line comment. You also have multi-line comments in C. They start with the / followed by the star, and then they end by the star followed by the /. Anything that happens inside of this, this is the open multi-line comment symbol, and this is the closed multi-line comment symbol. Anything in the middle here is going to be ignored by the compiler. Oftentimes, C programmers will line up the stars so that you can see the multi-line comment very, very easily. You don't have to do that. Anything that's inside of this /* and this star / is a comment, and you can put anything that you want inside of that. So it doesn't have to be lined up like this. This is just a convention that C programmers often use because it's very easy to see the comment and where the comment starts and ends without having to look through the entire comment. Single line comments can also appear at the end of a line. If you have a line of code, you can have a single line comment right at the end of it, and the line of code will still execute. Starting from the two / to the end of the line is then going to be the comment, and that will not be executed or even looked at by the compiler. You can do the same thing with a multi-line comment. You can have the start of a multi-line comment on the same line as the end of a multi-line comment. And let me show you exactly what I'm talking about here. Let me open up a program here called TextPad and show you how we can do single line and multi-line comments in our program. So we saw this the other day of creating the main function and including our stdio.h. What we can do in here now is say here is where I print my string. So there's a single line comment. I could have done this as a multi-line comment instead. If I wanted to, I could have included the single line comment on the same line. it will still print out hello moose, and then it will have the comment, which is just ignored. And if you want, you can also put a multi-line comment where it's all on the same line. And as long as you end your multi-line comment on the same line, that works also. And then this is another print statement. And it will execute also. So looking at this code here, it would print out hello moose 4 times, and then it would print out another print statement. All of the comments that you see would be ignored. This code would compile and run. Okay, we're going to move into variable types now. In C, there are 6 different variable types. C++ has 7 variable types, and Java has 8 variable types. Here are the 6 main variable types that we have available to us in C. The first one is a character. We denote that by the keyword char, that's short for character, and a character is going to be 8 bits long. There are different character encoding schemes. So the 8-bit encoding scheme is the one that we use in the US. This is going to be ASCII encoding. If you're using a different encoding, such as EBCDIC, EBCDIC, or Unicode, then the number of bits for the character would be 16 or even more than that. But when you're using ASCII as your character encoding, which is what we use primarily in the United States, it would be 8 bits for your character encoding. We then have 3 integer variable types, short, int, and long. These variable types do not have decimal places. These are just whole numbers. Integer, the number of bits that we have in an integer is going to be equivalent to the number of bits that you have in your CPU. We talked in our previous lecture that most CPUs used to be 32-bit. Currently, we have a lot of our CPUs are coming as 64-bit CPUs, and we talked about addressing how much memory we can address based on the number of address bits that we have in our CPU. So with an integer, it's the number of bits in your CPU, which currently would be either 32 bits or 64 bits. A short variable type would have half the number of bits of your CPU, and a long would have twice the number of bits of your CPU. So a long variable type would have either 64 bits or 128 bits, depending on if you have a 32-bit or a 64-bit CPU. So that you can get a feeling for how many bits that actually is, let me show you here on the whiteboard. So if we have a number, an integer, which is 32 bits, let's say that we have a 32-bit processor, so we have 32 bits for our integer. That means that we can represent numbers that go from negative 2 to the 31 up to 2 to the 31. And we have a 0 in the middle there, so that's why we have 1 bit taken away on each side. The range of our numbers here then, let's see, that would be 2 times 2 to the 30. 2 to the 10 is about 1,000, it's 1024. 2 to the 20 is about 1,000,000, and 2 to the 30 is about 1 billion. So this goes up to approximately 2 billion is our range. So it's going to go from negative 2 billion up to positive 2 billion. If you need a number bigger than that, then you'd have to jump up to a long, assuming that we had a 32-bit processor. Otherwise, with a 64-bit processor, you can see 64 bits, that would take us up to a number, after billions, what do we get to? Trillions and so on after that. We're going to go up to another couple levels before we get up to the 64-bit. So the number is going to get quite large, quite fast. Most applications that we have, you could probably do just fine using a short even, instead of using an int. Int is a very common data type that is used very frequently. Short is not used nearly as frequently, although it probably should be used more, because we would be taking up less memory if we were using shorts as opposed to using ints all the time. But int is a very popular data type, so that's often the one that is used. So if you need something which has more than the number of bits that you have available to you, so let's say you even have a 64-bit processor and you're writing an application where you need more than 128 bits for your integer, what you would have to do is write a program where you have 2 longs, where the first long maybe represents the high order bits and the second long represents the low order bits, and you have a nice little sophisticated program that combines those together so that you create a new number. There are many applications that do that. There's a lot of encryption applications, security applications that use very, very large numbers, and they need numbers with very high number of bits. And so they will use 2 or 3 variables even together to do that. Encrypting right now, a lot of encryption standards are somewhere around 256-bit encryption, maybe 512-bit encryption. Really highly secure applications maybe even get up to 1024 or 2048 bits. You can see that to be able to do that when we only have variable types that are up to 128 bits, we're going to have to start combining them so that we can actually represent numbers that go up to 2048 bits. So we'll just combine multiple long variables so that we can represent larger numbers that way. We have 2 floating point variable types also, float and double. A float represents the number of bits that we have is the same as the number of bits in our CPU, and a double is twice the number of bits in your CPU. Floating point numbers allow you to have both a mantissa and an exponent. What this allows you to do is to have a whole number followed by decimals. So we can have decimal places. The short, int, and long do not allow you to have decimal places. It's just the whole number part. A float and a double will also allow you to have decimal places on your variable. Okay, getting to variables now that we know the different types of variables that we have available to us in C, how do we go about creating variables in our C program? A variable in a program works very similar to a variable in math. It can take on different values at different times. We assign values to it. We can have it be part of an arithmetic expression, different mathematical functions, and so on. So let's take a look at a little example I have here. How do we add the number 23 to 45 and store it in a variable named x? So here's a little snippet of code. So what I've done is I've created a variable x. I've said that the type of that variable x is an integer. So I said int followed by the name x, and then I put a semicolon at the end. All lines in C have to end with a semicolon. There are a few exceptions to that, which are the ones that have curly braces at the end of them, and you'll see a few more of those. We've already seen one, which is the main function had a curly brace at the end of it, so we did not have a semicolon, but at the end of our printf statement we did see a semicolon at the end of it. So here I've declared a variable. The name of the variable is x, and I've declared it as type int. I put a semicolon at the end of the line. After I've declared the variable, I now have the ability to use it. I can assign values to it. So the next line of code I have here says x equals, so I'm going to assign the value to x, and the value I'm assigning is the sum of 23 and 45. At the end of the line I have another semicolon. That then will assign the value 68 to my variable x. We can also create multiple variables and add them together. So you see here I've created 3 different variables of type integer, an x, a y, and a z. If I create more than one variable on the same line, I separate them by commas. So here's my variable x, which is an integer. Here's my variable y. It refers back to also be an integer. Here's my variable z. Refers back also to be an integer. I then assign some values to y and z. I assign the value 23 to y. Follow it by a semicolon. Assign the value 45 to z. Assign it, terminate it with a semicolon, and then I assign to the value x the value of y plus the value of z. So it's going to substitute in the value of y, which is 23. It's going to substitute in the value of z, which is 45. It's going to add those two numbers together, which gives me 68, and then it's going to assign the value 68 to my variable x. So the same result that I had in the little code snippet above, however, down here I'm using variables instead of just hard coding the numbers that are going to be added together and put into my variable x. The last line here, so we saw printf, so I'm going to tie this together with what we learned in our last lecture. If we want to print out what the value of x is, we're going to have our printf statement. With our printf, we open the parenthesis, then we follow it by the quotation mark. Anything that's inside of the quotation mark is what's going to be printed out to the user. It's actually going to print out x equals. So that's going to be printed out exactly like that, x equals. The %d now, if you noticed on the previous slide, I had a few of these special characters written to the right side of those variables. The reason I did that is if we want to print out the value of a variable, we actually have to tell the printf function, here is where I want you to print out the value of a variable. The way that we specify that is using that % followed by one of those characters. So if I go back to the previous slide, you see that if I want to print out a short, an int, or a long, I have to use this special code %D. If I wanted to print out the value of a character, I would use the code %C. If I want to print out the value of a float, I would use, or a double, I would use %F. So coming back here, you see that I do a printf x equals, it's actually going to print out x equals, and now I want the value of x. The way that I print the value of x is I have that % followed by a D, and then here, I know it might look a little weird, but this is just a \n, and we saw that last lecture also, which is just going to give me a new line. So it's going to give me a new line. So what this will print out is x equals the value of some variable followed by a new line. Now, what variable do I want to print the value of? I want to print the value of my variable x. The way I do that, after my close quotation marks, I put a comma and I follow it by the name of the variable whose value I would like printed in place of that %D. So it's going to print out x equals the value of a variable. What variable is it going to print out? The value of this variable x, which is after the comma inside of my printf statement. Then it's going to follow that by a new line. That closes my string, and then I close my parenthesis followed by my semicolon. So in this case, that line is going to print out x equals 68 followed by a new line character. Okay, I can also format my output a little bit more if I didn't want it to just say x equals, but I actually wanted the equation printed there. So you see here, I can just have my printf statement, open my parenthesis, open my quotation marks, and then just put the values in there. 23 plus 45 equals %D, the value of a variable. The value of the variable that I would like to print is x, that's after the comma, and then I have a new line character followed by my quotation marks, and then don't forget your closed parenthesis followed by the semicolon at the end of the line. I also have the ability to print out multiple variables inside of a single printf. The way that I would do that is shown here. I have my printf function, open my parenthesis and the quotation marks. Instead of hard coding 23 and 45, those were actually in the variables y and z. So inside of my quotation marks, I say %D. This is going to give me the value of a variable. And then I say a plus sign, followed by another %D. That's another value of a variable. Followed by an equal sign, followed by a %D, which is another value of a variable. So what I'm doing here is I'm saying I'm going to print out the value of 3 different variables. What variables do I want to print out? Well, after the comma, you see now I have 3 variables, y, z, and x. The order in which these variables appear is very important. That is the order in which they are going to be substituted in to the %Ds that I have inside of my string. So I say printf, have the first %D, the value of the variable y is going to be printed out for the first %D because that is the first variable that is after that comma. The second %D is going to get the value of the variable z because that's the second variable after it. And the third %D is going to get the value of the variable x. So what I'm going to end up with here then is the value of the variable y, which is 23, followed by a plus sign, followed by the value of the variable z, which is 45, followed by an equal sign, followed by the value of the variable x, which is 68. So this line here and the previous line both print the same thing. However, there's one major difference here. The bottom line is the preferred way to do this. What if your boss comes to you and says, you know what, instead of adding 23 and 45, we want to add 24 and 45. Well, all you would have to do if you had written the bottom line is change the value of this variable y to be 24, and it would automatically be reflected in the print line. However, if you were using this line right here, you would have to change the value of this variable here, y, to be 24, and then come down to your printf and also change the value of this here to be a 24. Programmers are inherently lazy, and we don't want to have to do more work than we have to. We want to streamline as much as possible so that I can change something in one place and it gets reflected throughout the entire program. This is one of the beauties of having variables in your program. What this also means, since your boss may not understand how well you write code, you could tell your boss, oh, that's going to take me at least an hour to do that. I got to find all the places where we use that number. You go back to your desk, you change it in one place, and you surf the web for the next 55 minutes. Okay, we talked about the different arithmetic operators that we have available to us in C in our last lecture, but I will review them here. We have addition, we have subtraction, we have multiplication, we have division, and we have an operator called modulus. What modulus allows us to do is to find the remainder of the division problem. So looking at this problem here, my variable b is equal to 34 mod 12. That means that I'm going to divide 34 by 12. That gives me 2. 2 times 12 is 24, and I have a remainder of 10. The value of b in this case is going to be 10. If we are dividing using integers, that would mean either a short, an int, or a long. When we perform the division, we will not end up with a decimal. We will only end up with the whole number part. So looking at the division portion there, where I have a equals 34 divided by 12, this is going to return to me 2. It's not going to return to me 2 and 10 twelfths, 2.8, nothing like that. It's going to return to me the whole number 2, because we're dividing an integer value by an integer value, which is going to give me an integer value. It does not round, it will chop whatever is left. So 34 divided by 12, even though it's 2 point something, the answer that's going to come back and be stored in this variable a is going to be 2. We don't have that problem with addition, subtraction, or multiplication, because when we have an integer added to an integer, we're going to get an integer anyway. Same with subtraction, same with multiplication. The only time that we have to worry about is with division. If you're doing division with integer values, which are short, int, or long, you're only going to get the whole number part. If you want the decimal part also, then these numbers cannot be integer types, they have to be floating number types, which means they will need to be either float or double. With the modulus operator, on the other hand, those are going to be integer types, because what we're trying to get there is the remainder. The remainder is always going to be a whole number. It's not going to be a decimal. The remainder is going to be a whole number. So in this case, the 34 mod 12 is going to return to me 10. We have order of operations just like you have in math classes. Modulus, division, and multiplication all have the same precedence. It's going to have precedence from left to right. Addition and subtraction have lower precedence, but addition and subtraction have the same. We can change the order of operations using parentheses. So here's an example of where I have two equations. The first one, we're going to use our order of operations, where C is going to get the product of 34 multiplied by 12, and then it's going to add 13 to that product. The second equation, where I have D equals 34 times, and then I put parentheses around the 12 plus 13, it's going to add the 12 plus 13 first and give me 25, and then it's going to multiply it by 34. If you want to have more than just one set of parentheses, you can. You were just going to nest multiple parentheses. We do not use brackets. We do not use curly braces like you would in a math class. I know that in a math class, if you had more than just one, you would probably do something like D equals 34. You can open up maybe a curly brace, and then you would have brackets to say something like this. Okay, we would not do that. The square brackets and the curly braces mean something completely different in C and in most programming languages. If we wanted to have something that worked like that, we would just have to nest our parentheses. So you can nest them, you just have to make sure that anytime you have an open parenthesis, you then have a corresponding closed parenthesis. So that would give you the desired effect from the previous one. I'll put a comment above this. This will not compile in C. So I will comment that line of code out for you. This would be the preferred way of doing that. Obviously, I need to declare that variable before I do anything like that. Oops. Looks like I'm missing some sign that I wanted in the middle there also. We can't leave the multiplication sign off. There's no dot operator similar to what you have in math classes. So I would have to include it like that. Okay, so that would work if we want to change the order of operations from the default. The default order of operations, modulus, division, and multiplication, have the same precedence, and they're higher than addition and subtraction, which have slightly lower precedence. Okay, there are a number of keywords in C. The only reason that you need to know about the keywords in C right now, there's two reasons. One, I've mentioned a few of them to you already. Double, int, short, long, float. Those are, and char. Those are keywords. Those are the types of variables that we have. You cannot use those words for anything other than what they were originally intended to be used for, which is creating variables of that type. You cannot use them for the names of variables. You cannot use them for the names of functions. You can't use them for anything else other than to declare a variable of that type. The reason that I show you all of these other ones right now We'll learn what a number of these mean, maybe even what all of them mean by the end of the semester. Don't worry about what they mean right now. The reason I show them to you is because you cannot name variables or name functions any of these keywords. Whenever you type one of these keywords into Visual Studio, it's going to turn bold and turn blue. And that shows you that it's a keyword. You're not going to be able to use that as the name of a variable. You're not going to be able to use it as the name of a function. When we get to it, you won't be able to use it as the name of a structure either. So just take note of those, and whenever you're in Visual Studio, when you type one of those keywords, it's going to turn blue. It's going to get bolded and turn blue, and I'll show you that today when we write our code in just a little bit. Okay, I went over this last class, but I want to make sure that you have it written down also. How do you set up a project, a C project in Visual Studio? So I've given you the steps here. I showed you a video on doing this last time. We're going to walk through this again today. Every time that we create a new program in C, we're going to be doing it in Visual Studio, and we're going to walk through these same steps. So you run Visual Studio, you go to File, say New Project. Under the properties, make sure we select the Win32 console project. Make sure you select that it's a console application. Check the empty project box, say OK. Add a new item, add a new C++ file, and then you have a blank file open on the screen. At that point, you then are going to be able to type your code. After you type your code, how do you run it? You're going to have to build it. This was the code that we did last time. We build it by going to build, project name. If there's any errors, we go through, we fix the errors, and then to run it, we go to debug and say start without debugging. I know that was kind of quick. I showed you that yesterday. We're going to do it again in just a second here. Every time that we write a program, you're going to do the exact same thing. So I'm going to wrap up this lecture right now. Your next lecture, we're going to be writing a program and following along with the steps. We're going to be using some variables. So I'll see you guys in just a few minutes.